So for example 1, you were asked to find the mean and median of the list of values and then answer some questions about removing the value of 85, which does appear in both lists. So in this situation here, the first one, if you're looking for the mean and the median, especially more so for the median, you want to have these items listed in order from least to greatest, because you need to have an ordered list when you do the median in particular. And if need be necessary, and if you want me to show you, I can show you how to do this in class on the calculator and have it sort for you, but it's something you're going to eventually have to do on your own for the final anyway, so you won't be usually given a huge list to do in that kind of situation. The mean is just the average, so you would add these all up to get a sum, and so if you added all these up, you would get 401. There are, in this case, 9 items here, so you're going to take that 401 divided by 9, and that's going to give you the mean, which is about 44.6. As far as the median goes, you're going to take this number here and divide it by 2, because you're looking for the middle score. If the value ends in a 0.5, that means you're going to go to the next term, the 5th term, and that's going to be your median. And so you would count off to the 5th term here, which in this case would be the 39, and that's going to be the median. Now, you're asked here, if 85 were removed from the list of numbers, would the mean be greater, less, or unchanged? Well, you can see here 85 is certainly much bigger than most of the other values. It's an outlier. There's ways of testing for outliers, but you really don't go into it too much in this course, but an outlier that's much bigger than most of the other things are going to tend to pull this greater. So if you remove this, the mean should decrease, so it should definitely be less. Whereas if you remove a number or add a number to a list of numbers, the median shouldn't change a whole lot. It really depends on the diversity of the numbers here. Now this one was set up that if you actually would remove this 85 and then go back and find the median, it would still stay 39, so it is unchanged. But keep in mind that there might be some slight change to it depending on what numbers are actually in your list and how varied the values are. So that's the only thing that's going to matter in those kind of cases. For this one here, again, putting these values in order. The mean, again, you're going to add these up, get a sum. You have 8 values here. And then you're going to divide 2995 by 8 to get the mean. You get 374.375. Now the median, if you divide this by 2, you get 4. If you get an integer value, that means that the median is going to fall to the right of this and before the next term. So it's going to be between the 4th and 5th values. That's where the median is. And what you would have to do then is take the average of those 2 values that surround it. And if you average 2 390s, you're going to get 390. So here, 85 is an outlier. You can see it's significantly lower than the rest of it. This value probably pulled this mean down as a result. And therefore, if you were to remove it, you would get a greater result. Whereas if you removed it and went down to 7 terms, your median would now be this 390 again. It'd be unchanged. It could be this middle score right here. So it would be unchanged again. And now both of these asterisks again, there could be a slight change or some change in the median because of the values that are in the list and how varied they are. But it has nothing to do with the values themselves, just where they fall on the list. In this next problem, you're asked, when comparing the price of an item that you wish to purchase, you found that 5 stores are selling the item for a price of $80, 7 stores are selling the item for $95, 8 stores are selling the item for $110, and 4 stores are selling them for $125. You're asked to find the mean and median price of this item. So here you're basically being described here a frequency table. You have 4 prices, and this is the frequency in which they occur. You can still do the same calculations as the previous one, except now you don't have a list of values per se. You just you have how many times each one of these occurs. So here, where these are your X values, your price, your N, your total number of stores that you looked at were 24. That's going to be important. if you take each one of these are going to give you like subtotals. So you had, you know, a total of $400 from these 5 stores, a total of $665 from these 7 stores. So you're taking basically the totals of each one of these stores and totaling them up. And it's these two totals that when you divide them give you the mean. So 2,445 divided by 24, that's going to give you the mean of about $101.88. The median, you're still going to divide this by 2 and you get 12. Since it's a whole number, you know that the median is going to be between the 12th and 13th value. So as you go down here and do these subtotals, your 12th score is a $95 if you have an ordered list. And the 13th would fall in the 110 range. You know, the next 8 of them are going to be in the 110 range. So your median is going to be the average of 95 and 110. So you would average those two together and you would get $102.50. In the last example, you were given these two scenarios and you were asked the quiz scores for some students in a college algebra course are out of 25, 16, 17, 20, 22, 23, 24, and 25. So they are giving you an ordered list. An 8th student has taken the quiz so that the mean score of the 8 students was 20. What did the 8th student score on the quiz? And these are types of problems that you might have even seen on Keystone exams back in the day if you're in the state of Pennsylvania. For this situation for the mean, it's actually not too bad because you have basically the sum of the first 7 that could be found. You're only looking for like the 8th score, you know what the average of the mean is. So basically, you know the mean, which is the sum over the total number of scores. In this case, you're going to have the 16, 17, 20, 22, 23, 24, and 25 all added together with an unknown score. We're going to call that x. And if you divide that by 8, that should equal 20. So you basically have a pretty set forth equation here. If you sum these up and simplify it a bit, and then you start solving this, you would multiply both sides by 8, subtract 147, and you would get that x is 13. So the last student scored a 13, which pulled the average down to 20. It's probably a higher average at this point. On the other hand, you have the same thing here, except now you're being asked if the A student, what did they score in order to get a median quiz score to be 21. This is the type of thing that I've seen in Keystone exams as well. This is a slightly more difficult one because it's a lot of logic going along with this. So, looking at the numbers you have listed. Now, currently there are 7 values in this list, and if you divide that by 2, you get 3.5, which means the 4th term is the median. So right now, the 4th term, or 22, is the current median. You know you want the new median to be 21, so you want to have scores added to this side of it to push this up and to end up with 21. Now there is no 21 here, so, and you know you're going to end up having a value of 8 for the total number, so you want the mean of the 4th and 5th term to be that 21. So this is going to be the new 5th term. You want the new 4th term to be 20 because you want this to average to 21. So you want the 5th term to be the 22, you want the 4th term to be 20. So either you could add another 20 to this list, and that would certainly do it, or you could add any other number prior to 20 in this list that'll push this 20 up to the 4th position, and then the 4th and 5th would average together. So basically, x could be any number between 0 and 20, and it would make the median 21. And so, set up properly and Top Hat's working properly, if you put any number between 0 and 20 in, it should work. Sometimes Top Hat's a little flighty though, but that is the end of this problem. And that's the end of this video. If you have any additional questions, please bring them up in class.